Hi, everyone. Today we are going to be talking about the states of matter. We've already talked about physical characteristics or properties of matter. So you should have a good handle on what matter is. And today we want to talk about the states of matter. We've got solid, liquid, and gas. And we're going to talk about different processes that can change the state of a piece of matter. Let's start off with watching this crayon video. It's called Melted Crayon Art. And you're going to notice that we're taking a bunch of crayons and placing them on top of a canvas. This is actually something that I've done before, and hopefully maybe I'll bring it in so you guys can see it. So what they're doing is they're just taking these pieces of crayon and they're placing it on the canvas. And now he is applying heat to the crayons. So the piece of matter that we're looking at is the crayon. As you can see, it starts out as a solid, and then he's applying, it's kind of like a hair dryer. So it blows out very warm or hot air. And you can see what happens to the crayons once that hot air hits the crayon. Doesn't that look so cool? So let's see if we can answer some questions. In your notebook, please write down these questions. The name of the substance. What is the name of the substance? So you would write down, we already talked about the fact that the substance is crayon. You can say it is wax, right? Because a crayon is made out of wax. You can talk about anything that you'd like to describe that substance. What happened to the substance? So you're going to explain what happened in this video to that substance. And you are also going, let me just move this right here. Okay. So you're going to explain how the state of matter changed. We already talked about the fact that it definitely did. And then you're going to answer the question, how? And then what caused it to change? So I'd like you to please hit pause, answer these questions in your notebook, and then come on back. There we go. So let's go to the next example. Oh, we already saw that one. We need to go to the next one. This is, as you can see, just a pan with some water in it. So let's take a look at what's going to happen to the water once the pan is placed on the stove. Hopefully most of you have seen this before. She's adding water to the pan. And oh boy, what did you just see? I'm going to go ahead and just rewind that for a second. And there is a change of a state of matter going on there. So watch when she pulls off the lid, what happens. You see that? That is another change of matter. So let's go ahead again and in your notebook, answer these questions. You're going to write the name of the substance. So that's going to be in your notebook. Then you're going to write what happened to the substance. Oops, hold on. I went up one too many. Okay, here we are. And you're going to answer the same questions. Write the name of the substance. Hopefully you know what that clear stuff is inside of that pan. Plus, I already told you. What happened to the substance? So what I want you to do is think about what happened when she lifted that lid. What did you notice? Did the state of matter change? And if it did, how? And what caused it to change? So go ahead and hit pause and answer those questions. So welcome back. You are going to now, in your notebook, check to make sure that you got the right answers. The name of the substance, of course, is water. What happened to the water? It boiled and then turned into water vapors. Did the state of matter change? Yes, it did. It changed from a liquid to a gas. And what caused it to change? Of course, again, the heat. Heat caused that to change. So let's take a look at the next one. So now we are given a solid, and that solid is gold. Let's take a look at what happens when we heat up metal such as gold. So you can see they have the metal, those big nuggets. They have that in a pan, and now they're going to place it into a very thick, a very dense pot, and they're going to heat it up. What do you think is going to happen to that metal once it gets heated up? Oh, look at that. They've got a kiln there. Super, super, super high temperature. Because remember, the melting point of something like gold is going to be extremely high compared to, say, melting chocolate or something that we would normally see melted. An ice cube, right? The crayon. Those temperatures did not need to be super high, but of course, for melting the gold, it has to be super high. So it looks like he's finished, and of course, he's being extremely cautious. And let's take a look at what that gold looks like. Looks like he's going to pour it into the mold and make a big brick of gold. Look at that. And again, you are going to answer those same questions. Write the name of the substance, what happened to the substance, did the state of matter change, and how, and what caused it to change. So go ahead and hit pause and write those answers. So write the name of the substance is gold. The gold melted. Did the state of matter change? Yes, it most certainly did. It changed from a solid to a liquid. And what caused it to change? Of course, that really high heat. But again, it's still adding a temperature change, which is heat, just like our other examples. So now we've got ice, instant ice. Now this is water bending in real life. This is super cool. So take a look at this. I'm going to go ahead and I just have to turn my volume up. Let me see. Hang on one second. I'm going to turn that up so you can hear. Okay. And here we go.
In just 3 easy steps, you'll be able to flash freeze a bottle of water just by touching it. Next, you'll learn how to freeze flowing water the instant it's poured from the bottle, and your training will be complete when you can eliminate the bottle altogether. Now, this might seem slightly supernatural, but you don't have to be a master to do it. In this project, we're discovering the secrets to ice bending in real life. For this project, we'll be using these bottles of purified water. I've got the 16.9-ounce bottles, and they've never been opened, so the water is extremely pure. Now, the secret to instant ice is just about as simple as placing your bottles in the freezer. I let these ones sit for 2 hours and 45 minutes exactly. And here you can see the water is still liquid, but it's actually cooled down to a temperature well below freezing. All it takes from this point is a sharp jolt to the bottle, and you can see the water flash freezes to ice right in the palm of your hand. How cool is that? You can also start the reaction by using an ice crystal, like one of these ice cubes. Just carefully remove the cap from the bottle and pour the water directly onto the ice. The water immediately begins to crystallize, giving you the power to create your own instant ice sculptures. The end result is a slush that has the consistency of a watery snowball, which of course is 100% edible and refreshingly delicious. Now try pouring your super cooled water into a clean glass and drop a bit of ice right in the center. You'll see the ice crystal begins to grow until it fills the glass completely. That's perfectly chilled for a hot summer's day. Alright, let's finish up by dipping just the tip of an ice cube in to see what happens. Within a couple of seconds, it's frozen in place, and the entire cup is solid. Well, now you know the secret to pouring yourself some instant ice and making water freeze on command. Now, if you'd like to see more of the technical...
Okay, so again, we are going to answer these questions. I think you have the hang of it now, so I'm not even going to read them to you. I would like you to please just answer them in your notebook and come on back. You can hit pause, come on back to get the answers. The name of the substance here was, we started with water. What happened to the substance? We got that water to freeze. Did the state of matter change? Yes, it changed from a liquid to a solid. And what caused it to change? Well, of course, temperature once again, but this time we went colder. So a colder temperature caused it to change. So here is where we are looking at some chocolate melting. Again, we're not going to go through this whole process again because the chocolate is going to be very similar to the gold, only the chocolate has a much, much lower melting point. Of course, you do not need as much heat to melt chocolate as you do to melt gold. So chocolate would be going from a solid to a liquid. You do not need to write this one in your notebook, just showing it to you so you can, all right, there we go. Okay, great job. Here are some other websites that you can go to if you'd like to find out about more molecules. You can find out about states of matter at chem4kids.com, the periodic table, and there's an element matching game as well. So go ahead and hit pause and jot these down if you're interested.